Pet Cost Predictor App, a peer-graded assignment for machine learning projects. Pet Cost Predictor App, useful for people who would like to have insight into future costs before deciding to take a pet. The problem? Pets can be really nice and sweet, but it's also a major decision. It affects your whole life and that of your environment. One of the key aspects of pets is the costs. You need to buy food, toys, accommodation, insurance, veterinarian bills, and for some pets, your electrical bill will be higher. Terrarium and aquarium, for instance. ML can help possible future owners make a decision based on the outcome. For who? People who live on a budget, or people who want to make their kids happy, but who are uncertain whether they can afford that cute puppy, or people who just want to know what a pet will cost. Now, people who consider a pet have to rely on the advice from the pet store owner or have to do extensive research. ML can do this for them by simply selecting the pet and the costs per month, year, or lifespan of the animal. This would be perfect as an app to use on a smartphone. So people can use it when they are in a pet store, for example. It can help people decide whether they can afford a pet, what kind of pet, food brand, etc. Here is a visual representation of how the app could look like. The user interface of the Pet Cost Predictor app is designed to keep it user-friendly and easy to operate. 1. User inputs: pet selection, species, breed, age, size. Lifestyle factors: living space, apartment, house, farm, existing pets, children. Cost preferences: food quality, budget, premium, insurance, toys, vet care frequency, energy usage for terrariums, aquariums. Time frame: monthly, yearly, or total lifespan. AI consideration: make input options intuitive and structured for predictive modeling. Use sliders, drop-downs, and simple toggles instead of free text wherever possible to reduce ambiguity. 2. Outputs: cost estimates. Display expected costs per month, year, lifetime, broken down by category: food, vet, toys, utilities, insurance. Visualizations: use graphs or bar charts to show category-wise contributions. Comparisons: allow users to compare multiple pets or cost scenarios side by side. AI consideration: show both point estimates, e.g. average cost, and ranges to reflect variability. 3. Transparency: explain predictions. Include a short note like, cost estimates are based on historical data from similar pets and may vary depending on your location and choices. Data source disclosure: mention whether data comes from vet records, pet store databases, or user surveys. AI consideration: avoid black box outputs. Users should understand why the app predicts a certain cost. 4. Communicating uncertainty: ranges and confidence intervals. Display $50, 80-month rather than a single number. Scenario simulation: allow users to see low-cost and high-cost scenarios based on different choices: premium food, frequent vet visits. Risk indicators: use icons or color coding: green, low risk; yellow, moderate; red, high, to highlight variability or potential surprises. AI consideration: communicate uncertainty without overwhelming the user. Keep it visual and intuitive. 5. Feedback loops: user updates. Let users log actual expenses after getting a pet. Model improvement: use anonymized feedback to refine predictions for future users. Alerts and tips: if actual costs differ significantly from predictions, provide suggestions, e.g. cheaper food options, insurance. AI consideration: continuous learning improves accuracy and personalizes predictions for similar users. 6. UX summary: simple and interactive. Guided inputs, sliders, and comparisons. Transparent and trustworthy. Clear explanation of how costs are calculated. Insightful: breakdowns, visuals, ranges. Adaptive: learn from user feedback to improve future predictions. The user interface should be friendly, calm, easy to use, and give an estimated prediction of the cost of a future pet. The privacy, ethical implications, and bias considerations of the Pet Cost Predictor app. 1. User data privacy. The app may collect sensitive user information such as income or budget details, household composition, ECG, kids, elderly, allergies, location for vet cost estimation. Users may also enter preferences that reveal lifestyle information. Ethical concern. Misuse or exposure of financial and personal information could harm users. 2. Data handling. Ethics. Transparency is crucial. Users should know what data is collected, how it is used, how long it is stored, who has access. The app should minimize data collection, only collect what is necessary to estimate pet costs. 3. Privacy approach. Anonymization. Remove any personally identifiable information, PII, before processing. Local processing. Perform calculations locally on the device rather than sending sensitive data to a server. Data encryption. Encrypt data in transit and at rest if storage is necessary. User control. Allow users to delete their data at any time. 4. Applicable privacy laws. GDPR, EU. Requires explicit consent for personal data collection and allows users to request deletion. CCPA, California. Grants consumers the right to know what data is collected and opt out of its sale. COPPA, US, for kids under 13. If children use the app, parental consent is required. Sources of bias in the Model 1. Data bias. If training data for pet costs comes primarily from urban areas, rural users may get inaccurate estimates. Regional differences in vet costs, food brands, or utilities may not be well represented. 2. Demographic bias. Income-based assumptions may disadvantage lower-income users by discouraging pet ownership even if feasible. Cultural preferences for pets may not be captured. 3. Product or brand bias. Using data from a single retailer or brand could skew cost predictions. Strategies to mitigate bias. 1. Diverse data sources. Collect cost data from multiple regions, retailers, and demographics. Include pets of different sizes, lifespans, and care requirements. 2. Transparency in predictions. Show users how costs are estimated, e.g., range versus single number. Allow adjustments for user-specific variables, location, preferred brands. 3. Regular model audits. Monitor predictions for consistent overestimation or underestimation across groups. Update data periodically to reflect real-world changes in costs. 4. Fairness in recommendations. Avoid nudging users toward expensive pets unless justified by their budget. Provide options for budget-friendly alternatives. Summary. The Pet Cost Predictor must balance usefulness with ethical responsibility. Privacy can be protected by anonymization, local processing, encryption, and user consent. Bias can be mitigated by using diverse data sources, transparent predictions, and periodic audits. Adhering to GDPR, CCPA, and COPPA ensures compliance and user trust.